Before we get into the sine and cosine rule, we can do a bit of revision with trigonometric functions. Trigonometric functions, you can use the standard sin, cos, and tan when you have a triangle that is perpendicular. So this symbol just means that it's a perpendicular angle. So when you look at angle A, you can see that this is the opposite side, this is the hypotenuse, and this is the adjacent side. So the sine of A is going to be opposite over hypotenuse. Cosine of A is adjacent over hypotenuse. And tan A is opposite over adjacent. So you basically use the sine and cosine rule when you have an obtuse triangle or a triangle that doesn't have a perpendicular or 90-degree angle. So when to use the sine and the cosine rule. So let's say you have a triangle where you have this side and this side, and you have this angle. Or when you have this side and these two angles, which is basically a side and an angle opposite of the side, then you use the sine rule. And the sine rule will look as follows. So when you have a triangle, let's say this is side A, this is side C, and this is side B. And this is, this is angle A, this is angle B, and this is angle C. So it's basically just the opposite of your side will be your angle. Now the sine rule looks as follows. The sine rule can be split up into two equations. It depends on which unknown you have or which value you want to calculate. So you can write it like this. Or C over sine C. But you can also rewrite it as follows. You can write it like this as well. If you want to find an angle, then it's just easier to work with the algebra when the angle is on top of the fraction in the numerator. Let's say you have a triangle where you have this side and this side and this angle. Or when you have a triangle where you have all of the sides, then you use the cosine rule. And the cosine rule will look as follows. So we are going to label it the same as the previous triangle. C. And your angles A, B, and C. And now the cosine rule, it looks a bit like the Pythagoras formula. And the cosine rule looks as follows. So when you put the a squared first on the left-hand side of the equal sign, then you have to use its opposite angle, which is capital A. You can also calculate the area of a triangle that doesn't have a perpendicular angle or a 90-degree angle, but it should have this side this side, and lastly this angle. So we can label it like this. Let's say this is side A, this is side B, and this is angle capital C. And your area formula is going to look as follows. Half of AB times sine of capital C. And that's how you calculate the area of a triangle that doesn't have a 90-degree angle in it. The example we're going to cover comes out of a GCSE Mathematics Paper 2. It's question 18 in the question paper, and it counts 4 marks. And they give you some values. They give you 3 angles and 2 side lengths in centimeters, and they ask you what is QS. And they also want the answer in 3 significant figures. So how I would tackle this question is I would look at QS first, the QRS triangle, which is this triangle. And I want to see how I can calculate QS. And you can see that you have 2 angles, and that means that you can use the sine rule. So to use the sine rule, you can see that here's an opposite angle, opposite of QS, and this angle is opposite RQ. So now you know that you can use the sine rule to calculate QS if you work with the bottom QRS triangle, but you still need QR. So now you can look at the PQR triangle, this one, and you can look at all of the values that you have. You have an angle and you have 2 side lengths, and the angle is in between the 2 side lengths, which means that you can use the cosine rule. So for triangle PQR, the top triangle, we are going to use the cosine rule. So the cosine rule, I'm going to write it in terms of all of the vertices of these triangles. So I'm going to write it as follows. So it's going to be QR squared is equal to RP squared plus PQ squared minus 2 RP PQ cosine of the angle RPQ. Now I'm going to substitute all of the values in. There you have substituted all of your values in, and now you can use algebra to get QR, which is going to be as follows. I like to keep my calculations, the decimals, as much as possible to ensure that my answers are always accurate. So because the more decimals you use, that means that it's going to be more accurate. So to get rid of the exponent, you take the square root of both sides. And doing so, you get QR as 5.009975 and so on centimeters. Don't forget the units. Now you have QR. So you have this length. Now you can use the sine rule to get QS, and thus you will have your answer. So for triangle SRQ, we are going to use the sine rule. And there you have your sine rule. And if you can, with all of the decimal points, put it in your calculator's memory and then use it in the following calculations so that it's more accurate. And now, to get QS on its own, you times both sides by sine 88, sine 88, and thus, when you plug 5.009975 over sine 41 times sine 88, you would get your QS as 7.631818 and so on centimeters. But if you remember, the question said that your answer should be in 3 significant figures. So if you round this off to 3 significant figures, you should get 7.63 centimeters as your final answer. And there you go. You got all 4 marks for question 18. Thank you so much for watching, and I hope you know a little bit more about the sine and cosine rule now.